Hi guys, in this video we're going to talk about the reactions of alcohols. Now please don't be frightened by this enormous figure that's on the screen here. We're going to go through these individually, and I've also provided you a hard copy of this little flow chart as well. But let me just go through there's three main reactions that we're going to talk about with alcohols. So if we start with our alcohol here, and we look at the three main types of reactions. First is oxidation. Second is dehydration, and then lastly, esterification. And I've provided the types of reagents for each of these three main classes. Let's look at oxidation first. In a prior video, we actually looked at this specific branch of this, the oxidation of alcohols. So if you use a strong oxidizing agent, a manganese or chromate type oxidizer, we've talked about before how if you have a primary alcohol, that will get fully oxidized to a carboxylic acid. A secondary alcohol will get oxidized to a ketone, and then tertiary alcohols have no reaction. So we've actually already talked about that little section right there, but I wanted to have it in the overall context of this larger figure. Two other types of reactions that we really haven't talked about yet are the dehydration of alcohols, and this requires reagents sulfuric acid, H2SO4, and then heat. And then the second type is esterification. That's going to require a carboxylic acid or a phosphate. So let's take a look at the dehydration one, and then we're going to go through a couple examples of both of these types. So dehydration. Now, if I use an excess of sulfuric acid and a higher amount of heat, 180 degrees, this is going to eliminate water or do a dehydration reaction to give an alkene. Conversely, if I use excess alcohol and a little bit lower heat, 140 degrees, this is going to give us a compound that's called an ether. Okay. Lastly, this last third type of reaction is the esterification. If I use a carboxylic acid and combine it with my alcohol, I get a group called an ester. Be careful not to confuse ether and ester. And lastly, if I add a phosphate to an alcohol, I get what's called a phosphate ester. So in this next section, we're going to take a look at some specific examples of these two types of reactions. So let's go through an example of dehydration of an alcohol. And the first one I'm going to look at is this condition here where I have excess sulfuric acid and then a higher heat, 180 degrees. Now, whenever you see these reagent combinations, be thinking alkane formation. So let's just look at a simple example of this. Let's look at 2-butanol. So under these reaction conditions, what happens is the sulfuric acid is acting as an acid catalyst. And what it's going to do, it's going to initially protonate the alcohol. So the OH with its lone pairs of electrons picks up a proton. And we now get this intermediate that you'll notice has essentially what looks to be a water molecule sort of attached to our butane chain. So in another reversible step, and I've put this in a bracket here because this is a fairly unstable, sort of short-lived intermediate. But if this water basically just falls off of the molecule, if the two electrons in the O carbon bond simply pull away to quench that positive charge, we would then release water. And now we would have this intermediate. Okay, so notice that carbon now, because it doesn't have that extra pair of electrons, is positively charged. This is called a carbocation. All right, we're not quite done with this reaction. What will happen next is that an adjacent hydrogen is going to be pulled off by water to now make our final product of this, which is an alkene. Now notice that I pulled off the protons here. In general, if you have a choice between making a di-substituted alkene, or if I were to pull off the protons in this end, that would make a mono-substituted alkene. In general, you want to try and choose to make the more substituted alkene. We won't worry too much about that in this class, but that is called a specific rule. It's called Zaitsev's rule. I won't go too much, though, more into that. But overall, look at what's happened. Okay, we've removed a hydrogen and an OH in the overall process of this reaction. We've gone from an alcohol to an alkene, and because we've removed this water, this is called a dehydration reaction. Okay, so the bottom line is, under these reagent conditions, sulfuric acid and high heat, 180 degrees or higher, you typically will then eliminate water. The alcohol will be converted into an alkene product. In this second example, we're going to take a look at the dehydration of alcohols, but in this case, we're going to look at reagent conditions that have an excess of alcohol and 140 degrees for heat. So this is a little bit lower heat than the prior example. This is going to be ether formation. All right, so let's just look at a simple example here. We'll take ethanol. So if I have a mixture of ethanol, or just a solution of ethanol, and I add in, I do need to add in, has an excess of alcohol plus H2SO4. Do have to add an acid catalyst for this. What can happen is the following. I'm going to draw this in the following way. I'm going to put two ethanol molecules next to each other. Like we saw before, if I have a lot of acid in my solution, one of these can become protonated to now make, this would be a reversible reaction, this. Okay, and now my other alcohol that hasn't become protonated can now react in the following way. So the OH of one ethanol is going to now react with the carbon of this protonated alcohol, and notice now that water would be removed. Okay, and the resulting product, let's just put an asterisk next to this carbon here. The resulting product is a new functional group. This is now called an ether. So when you use excess alcohol, and in this case we would just use a solution of pure ethanol, if I were to add some sulfuric acid and heat it a little bit milder heat, 140 degrees, what would happen is this dehydration reaction would occur to make an ether. This is a little different mechanism than the prior example. In our class, we're not going to worry as much about the mechanism. What I really need you to know, though, is that alcohols, under these reagent conditions, give ethers. So with excess alcohol, 140 degrees, there will be a dehydration reaction to form this new functional group called an ether. In the next type of reaction of alcohols, we're going to look at the esterification reaction. We're going to come back to this one many, many times throughout the semester. So in general, what can happen is if I have an alcohol and a carboxylic acid, and I've drawn them this way for a reason. If you mix these two together, the following reaction can occur. The alcohol can react at the carboxylic acid carbon, and what will happen is this OH group will ultimately be pushed off of this molecule to now give me the following. Okay, and so what's happening here is the OH of my carboxylic acid and the proton of my alcohol, those two are going to combine to form water. So the esterification reaction is a type of dehydration reaction. It's the coupling of an alcohol and a carboxylic acid to give us now this new functional group called an ester. And the ester bond is actually this new bond that's been formed right there between what was the carbonyl carbon and the oxygen of the alcohol. So as an example, if I were to mix, say, methanol and acetic acid. If I join those two together, the resulting product now would look like this. Okay, so the carbonyl group of my acetic acid is now going to become joined to the oxygen of our methanol, and we've now formed our ester functional group. This is the new bond that would be formed. So that's the basics of esterification. Again, we're going to come back to this type of reaction in many, many different formats and times throughout the semester, but a very, very important reaction that alcohols want to undergo. We just have one more to cover. We'll do that here in the next section. All right, and the last type of reaction that alcohols can undergo, we're going to discuss the formation of a phosphate ester. To do this, you need an alcohol and a phosphate group. Let's just draw out what a generic reaction might look like. So here is our alcohol, and a phosphate looks like this. Now I've drawn what's called phosphoric acid, or H3PO4. Now phosphoric acid in solution may not have all of the protons on there because it is somewhat acidic, but this is what a phosphate group would look like if all the protons were on it. So if I were to now join the alcohol and the phosphate, all right, what will happen is that the oxygen and the alcohol can join now with the phosphorus, and one of these OHs is going to basically fall off. It really doesn't matter which one. I'll just say it's this one. And then the resulting product would look like this. This is now called a phosphate ester. The new bond that we formed is right there. Notice that in the forward reaction, we're removing OH. So this is coming off OH. And again, the hydrogen of the alcohol, that's going to come off as water. And we now form this new linkage called a phosphate ester. Ooh, that kind of ran off the screen there. Phosphate ester. These type of reactions become really important in metabolism, primarily when alcohols react with a compound called ATP, or adenosine triphosphate. So let me just show you what that might look like. Let's say we had a simple alcohol. Let's just use ethanol. This may not be a real reaction in the body, but we'll just call it that. And I'm going to react it with ATP. Now I'm going to abbreviate ATP. I'm just going to abbreviate these phosphates as just a P with a circle around it. But what can happen is the alcohol can become phosphorylated to give us now the phosphate ester. And in this case, ATP will be converted to ADP, which would just have two phosphates attached. Okay, so in this case now, this would be the new phosphate ester bond. So that summarizes now the major reactions of alcohols. Again, there was oxidation reactions. We covered those in a prior video. And then our two new sections, which were the dehydration reactions and these esterification reactions. So please make sure you review those and get a little practice doing them. These will be very important as we proceed through the semester. Good luck.